Hi there, I'm Nix, and today's video is all about solving the minimum size subarray sum problem on the LeetCode website. As always, doing this in the C++ language and giving you a detailed explanation of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of its time and space complexities, as well as looking at the LeetCode rankings. If that sounds interesting to you, then stay tuned. Welcome back, and let's get started. We are given an array of positive integers, nums, and a positive integer, target. We want to return the minimal length of a contiguous subarray of which the sum is greater than or equal to that target. And if there is no such subarray, then we want to return 0. So in other words, we want to go through the array, and we want to find the smallest subsection of numbers that when added all together either are equal to or greater than our target. And for this first example here, that's when we add up 4 and 3 at the tail end of the array. Only 2 numbers are needed for that condition to be met, so our output is 2. The other example of note here is example 3, where our target is 11, but our array is filled with nothing but 1s, and unfortunately we don't have 11 of those 1s, so there's no way for us to get to the target. Thus our output is 0. Now looking at constraints here, the nums array can potentially get to be fairly big, so that means that some brute force answers may not be fast enough in order to be accepted. Now, if you optimize a brute force method somewhat, it could potentially work. So what we're going to do in this video is first go over a brute force method that, fingers crossed, hopefully works. And after that brute force method, we're going to take a look at the optimal method that runs in O of n time, and as a bit of foreshadowing, uses another technique than the brute force method. Hint, hint. So with that plan, how do we solve this problem? Well, going through this array, we can start at the beginning and add up the numbers until we reach a sum that's greater than or equal to our target. Once we have that, we can count how many numbers we had to add. In other words, the length of this subarray, and we can store that away. We can then move on to the next value, continue adding up our values until we get to an addition which gets us over a limit. We have that count for this subsection, and we want to compare that current count that we have to our old count. And whichever is the smaller one, we want to record that into what is essentially going to be our final answer. You do that over and over and over until you finally get to a point where you've gotten through the entire array, and you, if it exists, you will have found the smallest subsection. So going through that logic keys us into a couple things that we're going to need to do and we're going to need to use in order to craft that code. First up are the variables we're going to need. We know we need an integer variable to record the sum of the numbers that we're adding up. We need an integer variable that records the count, and we need an integer variable that is going to serve as our final answer, the minimal length of the subarray. Then, going through that array and adding up all of the numbers until we hit our target or greater keys us into the fact that we're going to need to use some nested loops. For every value in the array here, we want to add up values in the array until we get to our target. So our outer loop could be a for loop that is our usual setup, starts at the beginning of the array and goes until the end, and iterates up each time. But now, what is going to be our inner loop? Well, our inner loop, depending on the values that we see, we could essentially, if we ever saw a 7 in this array here, well, adding up that one number already gets us to our target. So it could run once, or as in the case in example 3, we could go on and on and on, continuing to add until we essentially bump up to the end of the array. So we don't exactly know how many numbers we're going to need to add up in order to get to our target, if that's even possible. And in that case, that's a great indicator to use a while loop. And our while loop is going to run until we either get to a sum which is greater than or equal to our target, or we get to the end of the array. So as long as those conditions are valid, we haven't yet reached our target, and we haven't yet reached the end of the array to avoid causing out of bounds issues. We're going to add up our sum, we're going to increment up our count, we're going to do comparisons once that sum is greater than or equal to our target, and then once our sum is greater than or equal to our target, then we're going to compare our minimal length and our current count and reset the minimal length to whichever one of those is the smaller one. Then at the end of that loop, we want to reset everything, so count goes back to 0, our starting place goes back to wherever our index is for our for loop, and we do it all over again. Once we get to the end of the array, we then want to return our answer, which, depending on if we found a subarray or not, we're either going to return 0 or we're going to return the minimal length. So with that outline, let's move on to actually coding that out. Here are the variables I was talking about. All of them are integers. We have a sum that's set to 0. We have a count that's set to 0. And we have our minimum length here. That'll be our final answer. And this I initially want to set to something that really can't possibly end up being the answer. So it'll either be overwritten in the process of going through the loops, or if it's still present, that indicates that there is no minimal length that satisfies the target, and thus we can return 0. So a way to do that is, because the length of the array at maximum is 10 to the 5th, setting a minimum length to any integer larger than that value is going to work. And for just ease of use, I've set it to the macro int max, which is set to equal the maximum value that an integer can hold. But realistically, anything larger than 10 to the 5th is going to work. First up is the beginning of the nested loops. So this is the typical for loop, starting at the beginning, going to the end, and incrementing up by 1. Next is the beginnings of the interior while loop. So this is going to go as long as the sum is less than the target, and as long as we aren't at the end of the array. And for this, I'm going to use a different index, j, but now since I'm using j, I need to first create j. So before the while loop starts, create an integer j, and I'm just initially going to set it equal to I. Now the code for the while loop. Now as long as we're not at our target, well, let's continue adding up numbers. So we want to set the sum equal to itself plus the value in the nums array at position j. And then after we get that, we want to increment up j to get from one number to the next and the next. While we're also doing that, we also want to increment our count and record how many numbers are being summed up. Now once we get to a position where we've added what's going to be the final number in that section, because our sum is now greater than or equal to the target, we want to then compare the min length that we have and our current count. And we want to set min length to whichever one of those is smaller. And then reset the count, because at this point this is the last thing that's going to occur. The while loop isn't going to run anymore, so we want to make sure to reset everything. Now, resetting things doesn't just mean resetting count. it also means resetting our sum as well. So after the while loop has occurred, we want to reset sum to 0, and then when this outer for loop happens, j is in the right place. The while loop will start up, and both our sum and our count will be reset to 0 to start analyzing a new subsection. Finally, outside of the loops, we're going to return 0 if min length is still equal to that int max, or we're going to return minimum length in any other case. So now let's take a bit of time to go over this code and make sure, as we go line by line, we understand what it's doing before we start clicking buttons. So we have the example array here, and the first thing that's done is we create and set an index j to equal what I equals. And at the start of the for loop, I is equal to 0, so j is equal to 0. We know sum and count are equal to 0, and min length is a really big number. Now we're going to start going into our while loop, because sum currently is 0, that's definitely less than our target 7, and j is definitely less than the size of the array here, since it's also 0. So now what we do is we want to add the value of nums at j. J is 0, so the value at index 0 is 2. So 0 plus 2 is 2. And then, as you see here, once we do that, we increment j. So j is now 1. After this line executes, the count is going to iterate up. We've added one number to sum, so we record that one number. Now we check to see if sum is now greater than or equal to target. And it's not. So we come to the end of the while loop here, and we restart. It's going to add sum at nums j of 1, so we're looking at 3 this time. 3 plus 2, 5. Count goes up to 2, and now we're still less than or equal to target. J goes up to 2 from this line here, and now we go over again. The same thing happens when we add 1, so we're now at 6, our count is now at 3, and J is now 3 as well. While it loops around again, and we add the value at index 3 here, another 2. This time our sum is 8. Our count has gone up to 4, and j of course has gone up to 4 as well. But now this if statement's condition is going to evaluate to true, because our sum is greater than 7. Now we are going to compare our old minimum length to our current count, which is 4, and set minimum length to whichever is smaller. And currently, minimum length is set to a very large number, which is obviously bigger than 4. So, since 4 is less than very big number, minimum length now is set to 4. Our count is now reset to 0 as a result of going into this if statement. When we loop back around for this while loop, we see that our sum is no longer less than the target. So, we break out of this loop and come down to our final bit of code here, which resets the sum. We've gone to the end of this for loop. Now we come around again. I is now equal, thanks to the increment, to 1, and now when this line of code executes, it will now reset our j index back to where it should be at the start of that new subsection. Then the while loop goes on again, and on and on and on until it eventually finds this section. So going through one iteration of that, it looks like this code doesn't have any errors in it. So let's run it and see if LeetCode agrees. And it does. So let's submit and see if this code is fast enough to be accepted, which it is. Excellent. Of course, before we hit this button here, let's go ahead and look at our time and space complexities. Space complexity is really good. We only have integer variables here. We don't have any containers that depend on the input size that we're creating. So our space complexity is big O of 1, constant. For time complexity, this outer loop here is dependent upon the num's size. This inner loop is also dependent on the num size and dependent on the target. So in worst case scenarios, this could potentially go through the entire array, but realistically it's going to go until another variable, sum, is less than the target. Since they're nested, they are multiplicative. So you can think of this code as having a big O of n, where n is the input size, times m, where m can be equal to the sum of the values that is less than our target. But that's always going to be some portion of the nums array anyway, so you can realistically think of this as a big O of n squared, where we're leaving off the fractional constants because we don't care about them. So in other words, this is going to be a very, very slow algorithm, but pretty good in terms of your space usage. So I expect to be very, 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 low on this graph. This algorithm is probably just barely optimized enough to be able to get accepted, but anything slower than this one is probably going to be rejected for having taken too long. But we don't even show up on this graph here. In terms of memory, as expected, we're pretty high up in the rankings. But note again, this is a fairly small range, so the majority of the various solutions probably have not much in the way of memory usage. There are probably a lot of solutions that similarly take big O of 1 space to use. So that was the brute force method of solving this problem. Now let's go back and use a 2-pointer method to make it faster. So in the previous problem, we were going through the array until we got to our target value or greater. But for every number in the array, we were continually doing that. Instead of all of that repetition, what if once we get to a target that's greater than or equal to what we're looking for, instead of essentially recording that value and then starting at another position and doing it all over again, what if we just function more as an adjustable sliding door? Let's bring up my handy dandy whiteboard to make a better graphic that I can use. So we hit our target, and then instead of starting over at a new position, why don't we just cut off our starting point, shrink our section a little bit, and see if we're still equal to or greater than our target. If not, well, we can expand our section up to include a new value. If we're now greater than or over, we shrink it from the starting point again, reevaluate. If we're still at our target, great, we can chop off another value. As soon as we're below our target, we expand the section again, and we'll continue to do that until we get to the end and find our shortest subsection. Going through the array in that way is going to take linear time. So it's going to be an O of n solution. And the way we can create that kind of behavior is by using 2 pointers. One of our pointers can just be an index of the loop that we're going through. Our second pointer is going to be the one that serves as a record of where our starting point in our subsection is. And that will adjust as we move through the array. So to achieve that behavior, let's see how this code is going to change. I'm going to reset the code here, and we'll start on that second solution. Much like in the previous solution, we have integer variables here. We still have the sum, we still have the minimum length, but instead of the count, we have an integer variable to serve as a way to record the position of where the substring first starts. And we've set that initially to 0. Like before, we have the start of the for loop. This is exactly the same as the last one, but now we want to go ahead and add up each of the numbers that we come across. So sum plus equals nums I this time. Next up comes the while loop. And for the outer for loop, we want to continue summing up the numbers until we get to a point where our sum is greater than or equal to our target. Once we reach that condition, we want to then switch over to adjusting that sliding glass door and cutting off the beginning numbers in that substring and then reevaluate. So in order to do that, we need a while loop with that exact condition. As long as the sum is greater than or equal to the target, we're going to do stuff within this while loop. First thing to do is making sure our minimum length is set to the smaller of the two options. First option is what it's currently set to, and the second option is the current count of that subsection we're on. And the way to get that subsection is to take our index value, subtract our substring start, and then add 1. So for example here, once we get to this point where we've added 2, 3, 1, and 2 for a sum that's greater than or equal to 7, or sum being 8 in this case, we compare int max to I, and we've gone all the way to this position here. So our index is currently 3. So we take 3 minus our substring start, and substring start at this point is still equal to 0 since our section starts at the beginning of the array, and then we add 1 to it. So 3 minus 0 plus 1 equals 4, which is the length of this section. And this equation here is always going to equal the length of the section that you're currently looking at. So since 4 is less than int max, minimum length is going to be set to 4 now. After we get our minimum length, the next thing we want to do is chop off that beginning number to see if we can shrink our section. So turn this into this. Chop off that 2. The way to do that is we take our current sum and set it to itself minus that current value. And that current value is going to be and the nums array at the substring start. And then once we have that recorded, we want to make sure to increment substring start to ensure it points to our new subsection starting point, in this case at index 1 here. Now this while loop is no longer going to run because in this case we now have 3 plus 1 plus 2, which is 6. It's less than our target, so our while loop stops cutting off the starting point since we're now below our target. That will allow the for loop to continue, and when this line runs, we add 4 to our current section. The last thing to do is evaluate what to return. And it's exactly the same thing as last time, but I can, instead of using several lines of code here to do this, I can condense this a little bit more by using a ternary statement. So instead of this, we have this. This ternary statement does the exact same thing. It's going to return either 0 or min length, depending on whether this condition is true or not. If this condition evaluates to true, then we will return 0. If this condition is false, you'll return min length. And with that, the code is complete. So let's click buttons here. We get it to finish. We get the correct answers. Cool. Let's click the blue button and see if we get green text, which we do. Excellent. Now this is a cool code example because even though you have nested loops, because of the way they function, it is still a big O of n solution, as we see when we were analyzing how this code walks through the array. And it does so by that sliding glass door adjustment methodology. You never have that repetition you see in other nested loops, because this while loop is dependent upon what this for loop does due to the summation that is going on. So our time complexity is big O of n, and our space complexity is still big O of 1, but we've improved it a tiny bit by not having a fourth integer variable. We didn't need j present within these loops. So a little bit of a tiny optimization, but in terms of space complexity, it's still big O of 1. So let's look at the rankings and see that we are indeed now really high up in this distribution, which we would probably be able to ping pong around a bit depending on things, but certainly better than the 500 and something milliseconds we had initially with the brute force method. And we can see we're still well within our memory usage distribution, which again I would assume we can ping pong a bit around because of the narrow range. So with that was how to solve minimum size subarray sum in 2 different ways. I hope you found this video useful. If you did, consider subscribing. And as always, I will wish you happy coding and to have a nice day.